Nope. No. Stop it. Ballpark. Give up. Okay, try this one more time. We got this. One more time. See if I can crash the computer again. All right. It's recording and everything like that. Okay. So I am trying to figure out the slope at x equals 2, yeah? So x equals 2 is right here. X equals 2 is right there. Mr. Rast, why would finding the slope be challenging? Because it's changing. We know the slope is changing. Therefore, the old school draw two dots, figure it out, ain't going to work. Okay? So the first time people came across this little gem mathematically, they said, you know what? It kind of looks like it goes that way, sort of, right? You're going to say the slope starts this way, gets less steep, less steep. So right about here, it's about like that, isn't it? So they came up with the idea of something called a line tangent. In fact, they came up with that before because you learned about that way back when in good old-fashioned geometry. In geometry, what a line tangent is a line that touches at one place and is perpendicular to the perpendicular of the surface. Perpendicular surface would be that way, correct? So you're perpendicular to that perpendicular. We call that a line tangent. Okay? So what I do to figure out a line tangent is I'm going to need a ruler. Yay! Notice these are not swords. They're not eye-poking devices. They're not used to carve up your desk. Serve yourself while you serve your customers. Yard slogan ready. All right. So balance your ruler. So we are not going to learn the official way to do this. We're going to learn the quick way to do this. The quick way to do this is try to balance it so you got equal error top and bottom. Get your ruler as best you can situated. And then I'm going to draw a line. Oh, sure, now. Now, of course, now that I've drawn a line that I think represents the slope, the stem ridge. How do I figure out what the slope is or estimate the slope?
Follow the line.
All rise or run. So I'm going to pick two good places. This looks like a brilliant place. I don't have a second good place, so I'm going to go ahead and pick that spot right down here. My 2 points are 4, 6. And my other point is 0, 1.2.
Wait, how did you even draw the line?
Okay, let's try this again. I put my ruler, I balanced it on top of there. I made sure I had equal error on both sides. You know what I'm talking about?
No.
I demonstrated it in class. Were you here for that part?
What do you mean equal error?
Well, we know it's a curve, right? So I can't put the ruler on there and follow the line, can I?
No.
That's not a possibility. So I'm going to pick something where I think the curve is falling away from my ruler equally on both sides of the point I care about.
Okay.
Okay? And then I'm going to draw a line, and then I'm going to take my ruler, push it to the side so I can see my line.
Okay.
Then I pick 2 points on my line. Oops, I should probably take a moment. Actually explicitly do the slope formula, because some of you might have forgotten what that looks like. This is 4.8 over 4. I got 1.2. Is that the correct answer? Could be. Might be. I don't even know what that curve is.
That's like your estimated.
I'm estimating slope. Yeah, we call this a line tangent. Yeah? All right, now we're going to try to do the same thing for 4. Everybody have that? Looks like I got a rise and a run. So 1, 2, 1, 2, 3, 4. Looks like I got about 1/2. Ooh. Two people got the same answer.
Well, I connected those points.
Connect the point.
Not connect, but like make the ruler go to them. It's legit.
1/2 over here too. Everybody's getting 1/2. That's not bad. So that might actually be 1/2, right? Because we're all agreeing that's pretty much it, isn't it? Okay. All right, 0.6. I can live with that. It'd be rare if everybody got 1/2 and kind of step on one of my points. By the way, all right. Last but not least is a secant line. Okay. So pay attention to geometry. What's a secant line? Oh yeah, you got it? Yes, sir.
Well, you just draw a straight line from 1 to 4 to 5.
Nice. Nice. I don't remember anybody ever getting that right. It's possible that somebody got that right all the time, but I don't know. Here we go. That's a secant line. Okay? Draw a straight line between those 2 points. Yes, sir.
If there are like tangent lines and secant lines, are there like cosine lines?
No.
Cosecant lines?
No.
So like, why'd they just pick those 2?
Well, tangents derived from the original meaning of tangent, which is touching the corner and going past that spot. Okay? So a tangent is the connection between the 2 points of the extreme of a triangle, which is the same thing as the 2 points that would describe this point. That's a big geometry mess. I'm not sure why secant lines are called secant lines. I have no idea. But it's probably something similar.
Yeah.
Probably related to what secant is. Yeah. All right. Oops, now I'm off that. What's my rise? 1, 2, 3, 1, 2, 3. So what did I get for my slope? Yes, sir.
1.
Anybody not get 1? Okay, that would be troubling if you didn't get 1. This is not an estimation, is it? Secant lines give you an actual number. Yes. Tell me. Okay. So, why do we have to estimate slopes, Ms. Hunt, in this case?
Because we don't have like 2 exact points that can help us, so therefore we have like.
We have 2 exact
Yes.
points.
Well, we have to like guess something we don't know exactly where it is. Like slope is right because the slope is changing.
Slope is changing. It's a curve. Can't pick 2 points on the line.
Yeah.
When we do pick 2 lines, we get 1. Ms. Hunt, is 1 a better estimation of the slope here, or is the whatever we came up with 1.2? Which is better? 1? You think this is a better representation of what's happening at that point? This line right here would be better than the line we drew there, this tangent?
Maybe 1.2 might be a
Well, it might be a little better, right? Here's a problem. Can we agree that if it was a secant line, we'd be happier because we can do the math?
Yeah.
It's cake. We're doing the same thing we did before. We tried to find the slope of the line, right? But unfortunately, is it as accurate? No, that's a problem. So now we have this circular problem. We have to deal with the fact that, well, it'd be nice to bring a secant line, but it's not. Tangent lines are more accurate. So tangent lines are less accurate for us because we're estimating, right? So neither one of them are good math tools. We're kind of stuck in a bad spot, aren't we? Yeah. Okay. All right. Well, with that in mind, use a graph that is drawn on the tangent lines that I estimated for to find the slopes of -3 and 3 for this problem.
Where do we write it now?
On H, wherever you want to, on side, I can just pop the side.
Wait, so tangents are more accurate?